All right, welcome to this new video. As I explained in the previous video, the concept of rotations, and in this video we focus on the concept of reflection in 3 dimensions, okay? And let's look at this question first. The question is, find the matrix that represents the reflection across the plane x plus y plus z equal 0. Right, here's the representation. The plane here is given by this section, okay? This triangle is a section of the plane, okay? So this is the representation of this plane x plus y plus z equals 0. All right, once we have this, we want to define a new reference, capital X, capital Y, and capital Z, such that capital X and capital Y are in the plane, okay? And Z is orthogonal to the plane. It's a normal vector to the plane, okay? And for this, as you know, for the reflection, in the previous video, I gave the formula. We are looking for the matrix M, such that M is Q, R, let's say reflection, and Q transpose. Q here is the orthogonal matrix, and R, EF is the reflection, okay? First of all, we want to find vectors that form the orthogonal matrix Q here. All right, we choose then the first vector, let's call it U3, in this way, this direction. Let's call this is U3, okay? The vector U3 is orthogonal to the plane, and I'm choosing this simple vector 1, 1, 1. And being orthogonal to the plane also means that it is orthogonal to this capital X axis and capital Y axis. All right, once we have these vectors, we are looking for two U1 and U2 such that U1, U2, and U3 should be mutually orthogonal, okay? So what does that mean? We are looking for U1 and U2 that belong to this plane, okay? U1 and U2 is in this plane, while U3 is orthogonal to U1 and U2, okay? So we can just choose any vector in this plane. So we have let's call the vector U1 is equal, let's take a simple one. If you take this 1, minus 1, and 0, you can verify with me that this vector in this belongs to this plane, right? All right, once we have U1 and U3, we are looking for U2. We can use the Green-Smith theorem, but I don't really want us to use that here, but it's an option. We can do that, okay? So we can also use the fact that we are looking for a third vector. We have U1 and U3. U2 should be orthogonal to U3, and it should be also orthogonal to U2. So this is another way. You know, if you take the cross product, U2 is U3 times the cross product of U1. Remember that the cross product is given by this. Cross product, if you say U2 is the cross product, it means you take this, U3 is 1, 1, 1, this is 1 minus 1 and 0, okay? Cross product, if we start with the first component, right? We cross this, we obtain 0 minus 1, this is 1. Second, we cross this and we have 0 minus 1 with the negative sign from the formula is 1. And the last part, we cross this, we have minus 1 and minus 1. This is minus 2. All right, we have this vector. It is 1, 1, and minus 2. So remember that we are looking for this orthogonal matrix. We want to build this orthogonal matrix Q. And the property of the orthogonal matrix is that the vector forming the orthogonal matrix should be mutually orthogonal, right? And the norm of this vector should be 1. So if you look at this U1, U2, and U3, if you look at the norm, it's not 1. It means that we have to scale this vector in such a way that we obtain 1, okay? So let's look at this U1. If you scale U1, let's call it U1 hat. So it is U1 over the norm of U1, okay? This is what is the norm of u1 here? Is square root of 2. So this is 1 over root 2 minus 1 over root 2 and 0. Same for u2 hat, it is u2 over the norm of u2. This is 1 over root 6, 1 over root 6 and minus 2 over root 6. Third component, this is u3. u3 is 1 over root 3, 1 over root 3 and 1 over root 3. This is what we obtain, okay? Let's then build the matrix Q. If we start with the first component, u1, 1 over root 2 minus 1 over root 2 and 0. Second vector is 1 over root 6, 1 over root 6 and minus 2 over root 6 and 1 over root 3, 1 over root 3 and 1 over root 3. Now we need a matrix that reflects through the plane. So we need this matrix. If you look at this vector, u1, u2 and u3, you see that u1 is in the plane. So u1 is just 1 times u1, right? u2 is 1 times u2 because they all belong to the plane, right? Now for u3, given that u3 is orthogonal to the plane, then there will be a reflection, and this u3 will be minus 1 times u3. So these are the eigenvalues. We have this reflection. Matrix will be u1 is 1, 0, 0. u2 is also 1. So the eigenvalues 1, 1 and minus 1. Okay? We have the reflection matrix. We have the orthogonal matrix. We just have to use this formula. Making use of this formula, we obtain M. The matrix M is equal Q times the reflection R times Q transpose. So for the transpose, remember, if you forget how to find the transpose, remember that the transpose of Q, the first row become the first column, okay? And so on the second one will become the second column, and the third row will become the third column. That is the transpose of a matrix. So this is, all right, this is what we obtained. Remember that my objective in this video is not to show you how to do the matrix multiplication, because I assume that at this level you should be able to know how to do the matrix multiplication, okay? So if you can start with these two matrices, the product of these two matrices, you have a 3 by 3, and you multiply by this one, and you'll be able to obtain this matrix M. Okay, this is the reflection matrix that we were looking for, okay? So just to wrap up, we have to find the matrix that represents reflection across the plane x plus y plus z is equal to 0. And this is the plane, okay? We then define a new frame, capital Y, and capital Z, okay? Such that capital X and capital Y belong to the plane, okay? Because this triangle is the section of our plane, okay? So we choose capital X and capital Y in the plane, and capital Z is orthogonal to the plane. And we have to use this formula, find the orthogonal matrix Q and the matrix R. And once we have that, we just multiply, put them together, and obtain this matrix, okay? So I guess you understand this, and you should be able to do more. So in the tutorial, I'll give more example. And if you can't get this one, hopefully from there, you'll be able to understand the concept better, okay? That is all for this video. Thank you.